we're live.
That was pretty lame.
I wasn't ready for that.
Story of your life. Unit 2. Yeah, that's on the internet now too. We're looking at distance, velocity, and acceleration, which you do in Science 10. But Curtis, you really, in Science 10, they try and cram this notion of vectors down your throat, which I think they really overcomplicate. So we're going to try and make that a little simpler. But at the same time, they also try in Science 10 to, I think, give you these really generic approaches or equations. I'm going to try and be a little more specific. I think if I do my job right by the end of this unit, most of what you found difficult in Science 10, hopefully you'll be looking at like, I can do this in my sleep. That's my goal. And this is some of the fundamentals of physics. Part of what we're saying is in physics, we like to be able to calculate or predict or to measure things. So, distance, velocity, and acceleration. Lesson 1, frequency. For objects that have a regularly repeated motion, each completed motion is called a period. Let me give you an example here. I haven't got this little toy out yet, apparently. This really works better if I find somebody ahead of time. Good gosh, nope. Nope. Yeah, I know the recording software is going. People on the internet are going to be freaking out. That's all good. Okay.
Where did I put it? We're still live. We'll be right back.
Ah. Uh-oh, tangle? No tangle.
Here.
No tangle. No tangle. Here we go. Sorry for those of you who are at home waiting for this. Swing set. Imagine this is a swing set, okay? We would say the period is there and back, there and back, there and back. That is one period. Or, anybody else need the seating plan, by the way? Here you go. Circles. One period would be once around. One, 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 one. That's the period. Anything that has a repeating type of a motion, we say that if it's got a repeating type of a motion and that motion is regularly repeated, each complete movement is called the period. The time, sorry, good gosh, Dueck. It's called a cycle. The time is called the period. This is what happens. I was too eager to find my little science toy. Okay. So, as an example, rough guess, count in your head, what's the period? About 2 seconds? 1,000, about 1.5 seconds-ish, give or take. You can measure it much more accurately. Remember, though, the period is ending up back where you started from. So if it's a swing, fancy word for a swing is a pendulum. If it's a pendulum, it's all the way there, all the way back. If it's a circle, it's all the way around back to where you started from. If it's a spring going up and down, it would be all the way down, all the way back up to where you started from. Or if you started at the bottom, all the way up and back down to where you started from. A bungee jumper sort of has a period, except it gets shorter and shorter, so it's not officially regularly repeated, so we wouldn't quite call that periodic motion. It's called harmonic motion. Okay? Something called the frequency. Symbol for frequency, lowercase f. Most of the time, we'll pick clever, intelligent letters that match the words as symbols. Okay? Frequency is the number of cycles or revolutions, because that's a word that's often used in place of cycles, completed in 1 unit of time. Frequency is the number of cycles or revolutions completed in 1 unit of time. And as an example, car engines have a frequency of several thousand. What does RPM stand for, those of you that are involved in shop? Did you say revolutions? Okay, cycles. Per A minute is your unit of time. By the way, in physics, we never use minute as a unit of time, but they do in auto. Okay, revolutions per minute. That's a frequency. It's a bad frequency because it's not per second, but that's a frequency. Old records used to be called, what's a record, Mr.? The black vinyl ones from the old days, okay? Those used to come in 3 different sizes. Small, medium, and big. They were called 33s, 45s, or 78s. And that was actually frequency, the number of times they would rotate in 1 second, or it was their speed, I can't remember. We have a special frequency. The simplest frequency possible is once around every second. That's as nice as we can get. So 1 cycle per second, we give that a name. We call that 1 hertz, H-E-R-T-Z. Not just a rental company, that's actually a physics term. Named after a scientist whose last name was? Hertz. Yeah, go figure. Did you give me my seating plan already? You did. Sorry, brain did. Symbol for hertz? HZ. H is already taken by something, hours. So we can't use lowercase h. Uppercase H is taken by something called henries, which is a way to measure capacitance. Already taken. So HZ. Higher frequencies may be expressed in kilohertz. Hey, what did kilo stand for? What was the, yeah. Or megahertz. And you may have heard some of these terms recently in the news. They're talking about auctioning off new wireless mobile spectrum, and they're talking about what particular megahertz range those radio waves are. The government actually regulates and monitors. You're not allowed to broadcast a certain type of instrument at a certain type of megahertz or kilohertz because you'll interfere with all the other instruments of that type. So Wi-Fi has to be, it's regulated. It can only broadcast at a certain hertz. And then LTE or 4G has to be at a certain hertz. That's regulated by the government. Your generic cell phone signal has to be at a certain hertz. Radio waves have to be at a certain hertz. So megahertz, that was 1, 2, 3. So frequency is what? It's how many times you can go around in 1 second or 1 minute. Or, well, if it's hertz, by definition, it's 1 second. So something that's in the megahertz range, those radio waves are bouncing up and down 1,000,000 times a second. Really fast. Okay? Something that's in the kilohertz range, 1,000 times a second. The higher the hertz, I got to get this right. The higher the hertz, the more information you can pack on it. So it's nice to transmit lots of information, but it doesn't travel through stuff as nice. So the U.S. military, with their submarines that are underwater, they use something called, don't write this down, stands for very low frequency, and that, I think, is in the 10 to 20 hertz range. They're waves that are very, very, very long, and by that means they'll go through almost anything, but you can't pack much information on them. It's a compromise. Period. The symbol for period, sorry, the letter P is taken up by other stuff. The symbol for period, because it's how long to go around once, it's how much time to go around once, capital T. And the period is defined as how much time to complete one cycle. How long to go around once? How long to get back where you started from? On a swing, how long to go there and back? And I'm going to make the assumption that every one of you has been on a swing set at least once in your life, because there's some beautiful physics there. Okay. What's the relationship between the period and the frequency? Put your pencils down. I'm going to make up an easy example, and then hopefully you'll go, aha, and then we'll do a tougher example. Let's suppose that the frequency, don't write this down, let's suppose that the frequency is 10 hertz. That means you go around, listen close, 10 times per second. How long to go around once? If you can go around 10 times every second, how long to go around once? Think about it. Manny, oh, I thought you had a suggestion, sorry. If you can go around 10 times every second, doesn't that mean it only takes you 1/10 of a second to get around because you can get 10 of them in 1 second? Does that make sense? Okay. What if, don't write this down, the frequency is 100 hertz? It means you go around 100 times in every second. How long to go around once?
1/100 of a second.
What if, I'll give you a tricky one. .32 hertz. Spot the pattern. What? What's the relationship between period and frequency? And this is what you can write down. Pick your pens up. The period is just 1 over the frequency, isn't it? Isn't it?
Yep.
Oh, and by the way, that also means if the frequency is going to be 1 over the period, because if you go 1 over 32, you get just plain old 32. Or if you go 1 over 1, you get just plain old 100. I think, can someone check, is that on your formula sheet? If you have your formula sheet handy, Ben, you do? It'd be on the very front. I think I included that on there. Yes, I did.
Yep, there it is.
Okay, it's on there somewhere, so you don't have to memorize it, but I've just showed you that it kind of, if you think about it, you can intuit it. What that means, Rob, is I have no problem giving you either the period of an object or the frequency of an object and expecting that you can get the other one, no problem. It's the reciprocal. Is that all right? What you really want to do is remember what goes with what. So, one of the strategies I'm going to give you this year is memorize units. You can cut down on your mistakes. Kyle, you can cut down on your thinking an awful lot in physics if you know what units go with what type of measurement. Some of this you already know. Who remembers from Science 10 last year, what were the preferred units for velocity? Meters per second. What that means is if you're looking for a velocity in a question, all you do is you don't actually look at any of the numbers. You bomb your eyes along until you see a meters per second, and that's when your eyes stop and you say, that's a velocity. Who remembers from Science 10 what acceleration was measured in? Okay, so if you're ever looking for it, it's worth memorizing, because if you're ever looking for an acceleration, my Physics 12 kids don't even read the whole question anymore. They just, oh, there's a meters per second squared. That's the acceleration. Got to be. So, what are the units for frequency? I think it's capital H Z now that I think about it, or is it, or it might not matter. What are the units for period? Go look at the 2 examples that I just gave you and see what or the 3 examples. What did I write for? How can I remember that frequency is hertz, or that when I see something in hertz, that's a frequency? If I beat you with great frequency, it hurts. Stupid, but that's what I've used since I was in Physics 11. If I get beaten with great frequency, it hurts. Dumb, but it works, right? Come up with your own that's less violent, and I'll use that for the rest of my teaching if you can come up with something that's less violent and better. But the problem is the word hurts does mean... please... bail me out. Come up with something better, but this is what works. Okay? So let's try a little bit of this. Example 1. My favorite music station is located at 101.1 FM. If you look very closely on your stereos, it's megahertz. We don't say that, we just say FM 101.1, but FM is megahertz. By the way, FM stands for frequency modulated. Little physics word over there. How many hertz is this? Hey, this is great practice for your quest. This is a unit conversion. 101.1 megahertz. So I guess I want megahertz to cancel, and I want to end up with just plain old hertz. What can I replace a mega with according to my formula sheet? 10 to the 6th or a million? I'm going to write this in scientific notation, I think. 1, 2, 3, 4, 5, 6, 7, 8. 1.011 times 10. Listen to rock 1.011 times 10 to the 8th. Playing the latest hits. Doesn't quite flow as well. But that's what the units are. By the way, at this frequency, so that's the frequency, at this frequency, how many seconds would it take one of those waves to go past you? What's its period? Well, period is 1 over the frequency. Right? So I have this number on my calculator. Now, I got two options. I can go 1 divided by and use my answer button. However, I'm going to show you all a new button. This notion of taking the reciprocal shows up so often. Many of you will have a little tiny x to the negative 1 or a 1 over x. That's a reciprocal button, and it's a tiny bit less typing. If you do that, it'll say, oh, whatever your current answer is, I'll flip it. I get 9.89 times 10 to the negative 9. Reed, can you see radio waves? Because you know they are all around you right now. Can you see them? That's why. They're really short. They're really quick. That is what? 0.0000000099 seconds. So milliseconds. That's really quick. And you all, that's all part of the electromagnetic spectrum. So Rob is looking up. We can see regular light. You understand microwaves we can't see. That's why your microwave oven, you can't see stuff coming out of there. But if you could see microwaves, all of your cell phones would glow like flashlights to you, because your cell phones right now are all sending out microwaves like giant flashlight, microwave. They're sending out invisible microwaves to our eyes, but they're all around us. There's Wi-Fi all around us. There's all sorts of stuff around us that we never see. It's just there. Mr. Dueck's Harley Davidson, no, I don't own one, is cruising at 3,200. Read, what did RPM stand for? Per what? We're going to change that to hertz, which is revolutions per. Okay. This is a unit conversion question. What do I do first whenever I'm converting units?
Right now,
Let's write down what they gave me. 3,200, and I'm going to write revs per minute. I need to get rid of the minutes and bring in what? Where are the minutes in the first fraction this time, Jeff? On the top or on the bottom? Where are the minutes in this fraction this first time? On the top or on the bottom? On the bottom. Very good. So if I want them to cancel, since they're originally on the bottom, where do I want to put minutes in my conversion factor? Where do I want to put minutes in my conversion factor, folks? Top. Seconds go down there. Oh, but this isn't right. Minutes and seconds aren't. Oh, it's what's the conversion factor? How many minutes is how many seconds? So if I hear you correctly, Tani, I can go like that. Oh, I guess it's going to be about 53.3 hertz is the frequency. And I think it is capital HZ, because that's what I seem to be writing in this. I must have looked it up. That means that my Harley Davidson, the camshaft, which is what everything attaches to, rotates 53.3 times every second. How long to go around once? Oh, except I don't want to say how long to go around once. I have a fancy schmancy word for how long to go around once. What's the period? Because that is how long to go around once. Well, period is 1 over the frequency. Halen, did we just figure out the frequency? Yeah. Aha! 1 over 53.333. You know what? I'm going to use my fancy schmancy reciprocal button. The period, it looks like it rotates every 0.01875 seconds. I don't know how many sig figs to go to because I'm making up data. I didn't actually measure this, so we'll just write the whole thing. How many of you have been on the Revelation at Playland? It's a pretty intense ride. By the way, Physics 12, we do a field trip to Playland in May. I don't do it in Physics 11 because in Physics 12, we look at circular motion. We don't look at that in Physics 11. And aside from the roller coaster, what do most of the rides at Playland move in? A circle. So to analyze them well, you need circular motion. Okay, bumper cars as well. But everything else, everything else goes around and it's got a period, it's got a frequency, it's got some neat stuff. So anyways, the Revelation at Playland has a period of 1.8 seconds. What's its frequency? Frequency is the reciprocal of the period. And period is the reciprocal of the frequency. This is on your formula sheet, but I hope you're also saying it, and I can probably remember this if you want. It's going to be 1 divided by 1.8. So I'm going to go 1.8, take the reciprocal, which is the same as 1 divided by 1.8, but it's one less character to hit. Looks like it's got a frequency of 0.556. 0.56, let's say. Hertz. A fairly low frequency. A fairly low frequency. Because that's a fairly big period. Remember the radio wave had a period of like a billionth of a second? You can follow that with your eye, which is why you can see the Revelation moving. Your eyes can spot that. Turn the page, please. It says the recording timer in investigation 1-2. Am I going to fit a little lab? Yeah, we're going to see. Let's find out.